There are many commercially available garage parking aids, but this build is especially useful with its really bright display, easy installation, and 3D prints that allow for a nice integration onto your dash. The accuracy is also quite remarkable. When we reach a distance of 12 centimeters from guard to obstruction, we can verify this distance to 11 centimeters. So there is a 1 centimeter error, which is quite acceptable. The post-type parking aid comes alive with any movement detected by the RCWL radar unit, which in turn triggers a trip pipe configured as a one-shot, which in turn activates the Arduino with a BL53LOX and its system of LEDs and buzzers to guide you through to safe parking. A dot matrix display is used for the in-car circuit for better visibility. From power on, the BL53LOX begins measuring the distance from the sensor face to any obstruction in front of it. All values that are beyond its range are tagged invalid and displayed as such. The radar trigger unit was specifically designed to save battery power. This unit detects motion via the RCWL 0516 and triggers a 555 configured as a one-shot. This has a 1 minute high to keep the relay powered, which in turn powers the Nano so that it can do its thing. This LCD version of the parking guide is detailed in my instructables. The link is provided. The code for the YouTube version only powers the ultra bright LEDs and a buzzer. There are 4 distinct ranges that will trigger an instance, and these can be adjusted by you to suit your needs. Let's have a closer look at the circuit. CS, DIN, and CLK of the matrix display are connected to pins D10, D11, and D13 of the Arduino Nano. The BL53LOX has its SDA and SCL pins connected to A4 and A5 of the Nano. Now, with the circuit situated on the parking post, you can see that the battery pack supplies power directly to the radar, as well as the one-shot and relay units. Once motion is detected, the relay is activated and provides a regulated power supply to the Arduino Nano, which will then use the BL53LOX for sensing and guide you via the LEDs and buzzer to safe parking. For all my 3D prints, Captain Tape is used to cover the heating bed, and a simple glue stick is dipped in warm water and applied to the bed. This is done after the bed temperature is reached but before the nozzle temperature is achieved. These 3D print files can be found on Thingiverse and the code on GitHub. Links for the project are in the description. Also, check out my Instructables page for some unique projects. I hope you enjoy this build.